So this is a part that I didn't get to in class, section 4.1, extreme values of functions. Our goal today is to show you how derivatives can tell us where we have maxes and mins, and a couple theorems we're going to introduce, and this shouldn't take very long. But anyway, here's a random function y equals f of x, and I circled the key points along this curve, in which this first point here, we see that if we were to draw a tangent line, the tangent line would be horizontal. So we talked about that in class. F prime is 0 there, f prime is 0, ooh, sticking, f prime is 0 there, and then up here we talked also about this in class, in which f prime does not exist. Okay, and so this little top of a hill right here, we would call that a max. The little bottom of the valley, we call that a min. And these are local maximums and local minimums are where we have a high point or a low point, and then also we have another high point over here, and then we also, at the end of this interval here, the end of the domain at b, when x is equal to b, we have a local minimum, because it's the lowest point of all the points right around it. So if you just maybe draw parentheses right around that, and you can see there are no other y values close to that point that are lower than that point, so we have a local min. And likewise, over in the left hand side of this interval, we have another local min, and let me write that. Just write it like this. Just write a min like that, because nowhere along the curve here do we see a y value that's lower than that y value right there at the end point. Okay, so we're going to get into when do we have maxes and mins, and I need to pause the video and get the next slide ready. But what you should be seeing here is that certain things are happening when the first derivative of f is equal to 0, or when the first derivative of f does not exist, and also, though, critical things are happening to the graph when we have an endpoint as well. So back to our sketch here of y equals f of x. If we were to draw the x and y axes again, and we have again from a to b, what we have here, I don't know if this is going to work or not. Let me see. Oh, I can't do that. Hold on. So apparently, if I'm working on a PowerPoint slide, I can't advance the slide, but also annotate at the same time. Anyway, I'm going to go ahead and do this. The absolute minimum is right down there in the lower left. It's also called a local minimum. So what I'm doing here is I'm hoping that you guys are taking these notes, and so you can refer to your picture if you're being asked where do we have a local min, local max, absolute min, or an absolute max. Okay, these are also called relative extremes. So as you can see, local mins and local maxes, as well as absolutes, occur where the f prime is either equal to 0, or when f prime doesn't exist, and also at the endpoints of the interval. Okay, and so one of the main concepts here is that local extremes in the interior of a function occur only when f prime is 0 or when f prime is undefined. This is the only times you're going to have a max or a min. Okay, and so that's where we have horizontal tangent lines, or the derivative doesn't exist. So here's a theorem that you need to know, extreme value theorem. As long as f is continuous over the closed interval, then f has both a max and a min over that interval. So that's very important. Okay, max and min at interior points, max and min at the endpoints. And over here, we have a max at an endpoint, or a min at an endpoint, and a max at an interior point. So these are the different looks that you're going to see when you're viewing functions. Okay, and so we can have extreme values in the interior or the endpoints of a function. And I'm going to pause this just to make sure I give you exactly what you need here. Hold on a second. Okay, so basically what I'm doing here is I'm giving you guys just the basics, and then I'm going to ask you to do some of the problems on page 184, and then I will also do those as well. But anyway, just wanted to show you a few examples here. If we look at the graph of y equals x squared, we can see that the domain is all real numbers, and we can see also that we have an absolute minimum value, but we have no absolute maximum value. And this is consistent with the extreme value theorem. The extreme value theorem, remember, says that if f is continuous on a closed interval, then we have definitely an absolute max and definitely an absolute min. Well, this is not a closed interval, it's an open interval. If you go from negative infinity to infinity, that's called an open interval. It's not closed. Closed interval would be from one number to another number where both numbers are finite. Okay? And so we can see if we close the interval from 0 to 2, we have both an absolute min and an absolute max. So that is consistent with the extreme value theorem. Right here we see we have an open interval from 0 to 2. If you notice, there's an open circle down there at 0, 0. So we don't have a minimum value here, but we do have an absolute max. Okay, I might be going a little bit too fast, so I'll let you take a look at that. And then right here, we open the interval from 0 to 2, and so you should conclude that we don't have an absolute min, nor do we have an absolute max, because there's no highest point, there's no one number that's part of the graph that represents the highest point on the graph. Okay, so there is no one number. All right, same with the low point there. Local extreme values, and we talked about that as well. Let's see if there's anything else here I want you to see. Right, even though graphing calculator, we can use the graphing calculator to come up with the graph of the function, sometimes we need to actually go beyond our graphing calculator and study methods for finding whether values or functions are increasing or decreasing. And just to summarize, absolute extreme values are either maximum or minimum points on a curve, and they are sometimes called global extremes. And they are also sometimes called absolute extrema. Extrema is the plural of the Latin extremum. Okay, so all this is really fine and dandy. Very exciting too as well. A couple more things. If a function f has a local max or a local min, then if f prime exists, then it has to be equal to 0. Okay, so that's just another kind of a common sense theorem, because we know that absolute maxes or local maxes or mins only occur when f prime equals 0 or when f prime doesn't exist. So if the f prime does exist, then it's got to be equal to 0. And then finally, a critical point. This is very important that you understand. Critical point, it will be a point in which f prime is equal to 0 or f prime does not exist. And important things happen at critical points. Maxes and mins only occur at critical points. So this is something that you should write down. Maxes and mins only occur at critical points and endpoints. Okay, so it's like one of the last things I want you to kind of take with you after this. So max and mins can only occur at critical points and endpoints. Okay, so the bottom line is this. Maybe you can kind of see this coming. We're going to be given a function, and after being given the function, you're going to be asked to find the maxes and mins of that function, and so you just have to find the critical points, and then you have to test the endpoints as well. So that's it for now. I'm going to ask you to do problems. Let's see here. Let me actually write that down right here. So the last part of your homework is page 184, and you have to do 1 to 10 all, but then also 12, 13, and 19. And the 12, 13, and 19 are the ones that might give you the most trouble. But what I'd like you to do is try all of these problems, and what I will do is show a video showing you how to do all these problems as well. Send me a message if you want to know how to do any of the problems from page 111 as well. So the other part of your homework, just to make sure you have that down as well, is 1 to 10 all from page 111, but then also numbers 3 and 4 from that worksheet. that you were supposed to print out and bring to class for extra credit. And that's it for now. In the next video I'll actually show you how to do these problems, and but hopefully you've got the basics and you'll be able to apply those to be able to solve all these other problems. Okay, have a great night.